Welcome to the first talk of the 6-Fit Easy Build user meeting. This talk will be by Vasilios Karakias from the Swiss National Supercomputing Centre. He will be giving us an introduction to ReFrame, a talk titled Writing Powerful HPC Regression Tests with ReFrame.
Thank you, Simon. Did all of you had an echo? Oh.
No, it was okay for us.
Oh, I'm here.
You might have the YouTube stream open.
Oh, okay. You're right. Okay, so thank you, Simon, for the introduction and the EasyBuild community for hosting us. Some of you have certainly seen the presentation, a similar presentation in previous EasyBuild meetings. So I'm going to give some updates. I'm going to go over, again, for those that they don't know what ReFrame is, I'm going to again go over what it is. I'm not going to focus so much on the on code listings and things like that in this presentation. I'm going to be a bit more high level since now we have the tutorial for all the details. Here, just before starting, you can see the links for the GitHub project, the documentation, as well as the ReFrame Slack. And I will ask those that they're planning to attend the tutorial to join the Slack channel. And we also have, since a couple of months ago, a Twitter account as well. So make sure to follow if you want to get more updates. So as I told you, I'm the group lead of Scientific Computing Support Group. So basically, our key mandate in the group is to provide a sane environment to the scientists. We are mostly on the application level rather than on the system level. And there has been the question many of you have faced, how we can ensure that the user experience is unaffected after a system upgrade or a small change in the configuration. And we all know that HPC software stack is quite complex and very fragile sometimes, and also scientific codes. So we need a way to abstract the way the testing is done and make that more easy and more attractive, let's say, for the application people to write tests for the system. And then there are several things in there about how the testing can be made sustainable. How do you have consistent tests? I don't want one group, for example, to write in one way and other in another way. And then when the system gets upgraded, there is a mess of communication. So it's better if there is a single framework that we can stick to and be consistent. That also comes with better maintainability of the tests. And we don't want to have in each test all the details about how it interacts with the system. We want to move to abstract away the common part in a single place and maintained separately somehow, so that tests are independent of that. Portability is another big thing. We want an easy way on how we could migrate the same test to other systems, or if we set up a small cluster like we did for the ReFrame tutorial, we need to make sure that it is sane the environment, and we don't want to rewrite all the tests again. And of course, automation is quite important, especially when things are growing, and efficiency. We want an easy way to run, and we don't want to wait for ages. So all these are things that are challenges, let's say, for testing. And let's admit it, I mean, testing is, I mean, from software to even system and HPC application testing, it's not something very attractive, because it really requires the same level of engineering as writing the code itself. But we should definitely admit that it's much less attractive to write. And I bet how many of you have done really test-driven development instead of just jumping into and writing the features first, and then, okay, I might have to write a test. And the problem is, I see also myself, is that the value of testing is seldom visible in the short term as opposed to features. Also, testing has several levels. It's not just the unit test that you might run in your application. For example, ReFrame is unit tested, but it's not just that. Especially in application, you need high level like integration tests and so on, which you can't achieve necessarily with a unit test of your code. And then automation is another big thing, especially as projects grow. Initially, okay, I will run my tests every time I change something, but as projects grow, automation is really essential. And of course, we all know that testing can never be complete. So we will never have like tests that they really cover everything unless we have like real software verification and things kind of like that. But that's a general thing. HPC has another direction to system testing, because for us, the application teams, HPC has, as you all know, multiple interactive components from the hardware to the software, multiple compilers and programming environments, tool chains, MPIs, multiple libraries, multiple applications that we need to support, multiple architectures, and even multiple cluster. And what is quite important in HPC that makes it different from other types of environments is that it is high performance, and high performance does not go well with portability. And then so functionality and performance, so problems might arise in any place. And functionality in both performance and functionality are quite important. So you can have like a performant code that really does not compute what it should compute, especially in a scientific environment. And of course, you do need performance, and to ensure that performance stays across upgrades. And most of you have come across, and with all the intricacies of the software stack here, I tried to visualize this a bit. It's a very simplified view, but you can see all the different interactive components from that they might affect how an application runs. There can be a problem in a driver and can really screw an application. And then you have the compilers, the different runtimes, everything. And all these, if you start writing individual tests and ad hoc tests for each of those things, it really becomes unsustainable. So what is the HPC, or what has been until recently the HPC system testing landscape? Either was no or minimal testing. So whenever an upgrade, we're just jumping with the upgrade. We're going on with the upgrade and let users discover problems and open tickets, and we solve on the fly. Or it could be something minimal, like doing manual testing for each member of the staff, especially if you have large groups, which is not the case in most of the centers. To run its member has a set of tests that it maintains and just work on those. And then other solutions have been very ad hoc, very specific frameworks that usually you have tests that they're very tied to the site configuration. And sometimes you might end up with lots of unnecessary test code and application, which really has high maintenance costs and can lead also to low test coverage, because you can't just easily run tests or maintain them because essentially you'd have just to do copy paste. So this has started to change the recent years. One of the solutions is ReFrame. Later on, I have a slide with a couple more frameworks that are worth looking at. So our solution is, what we're aspiring with ReFrame is to create a generic HPC testing framework that allows you to write portable, not entirely portable, but essentially quite portable HPC regression tests that they're easy to move from one system to the other. And we're going to see that in the tutorial. And these tests are written in a high-level language, so they're written in Python. You don't need necessarily to know very good Python to write them. And this gives you also all the flexibility that the modern programming language and a high-level programming language like Python gives you in writing and organizing and maintaining your tests. One key aspect is that the framework abstracts away the system interaction details. We don't want anything in the test that ties it tightly to the system. We want to be able to port test different systems with minimal changes. And that comes along also, we don't want to pollute the tests with code that is not related to the logic of the test itself. That's helps in maintainability. And also ReFrame provides a runtime for running the tests, because we can run them efficiently and take advantage of parallelism and concurrency and these kind of things, so that you don't have to monitor your server, the scheduler, and things like that. The runtime will take care of doing that in a better way. So we have started, it's almost 5 years now, a bit less than 5 years. And we have some design goals, because we have really faced the problems. We had an in-house regression testing suite based on shell scripts. And so we have faced the problem. So we have faced the problems of maintainability, of portability, and this coupled, and the fact that tests were really coupled with the system. And we have struggled, the whole team, to just do simple bug fixes that were not related to the tests. So productivity was a key goal. So we wanted it to write tests easily. And portability, as I said, another one. We had 3 systems to maintain. Now we have 2 again, or 3 clusters, and we want to move tests around. And we want also speed and ease of use, because it's not us running it, our team, but it's also operations that they are actually running a subset of the tests. So we want to make it easy for them, that they don't want to write tests, or they don't necessarily want to bother with the application. We want to provide a nice and easy command line interface for them to run and inspect any errors and then contact us. And of course, robustness. Since we're talking about testing, we couldn't design a testing framework that wouldn't test itself. It could be really an oxymoron. So we really started with a test-driven design when we started with ReFrame, and actually it has already quite high coverage, and nothing gets in if it's not well tested and if there's no unit test around it. So this is a bit of the timeline. We started in March 2016, so it's almost 5 years. And by the end of that year, we moved in production along with upgraded. We had an upgrade back then of the big supercomputer, the Bitsdane. And then we decided to move publicly. Back then, we didn't even name the framework ReFrame. I think we named it internally as Pi regression or something like that. Then April 2017, we went public, just moving only the basic. In every release, we're just publishing on GitHub. And then in 2018, we moved completely the development on GitHub. And since then, everything is happening on GitHub. And yeah, we have gained already some popularity. I'm going to check the stars after the talk if you have started the repo. So please start. Actually, this is the documentation readers from last month, and we have around 150 unique users reading documentation, and are mostly US based and Europe. And yeah, so the project has been used, or there is an interest about it all over the world. So some key features about it. First of all, we support cycling through programming environments, or in easy build terminology is like tool chains. So you can associate a test with the tool chains that you want to test, and then ReFrame is going to cycle through them, reusing the same test, so you don't have to write specific tests for each tool chain. Of course, you can adapt your test and fine tune it for each tool chain, but it's not necessarily you have to write a complete new test by copy pasting another one. That's something that we never wanted to do. We have support for different workload managers, parallel job launchers, and any combinations of those. So you can use Slurm plus MPI run, Slurm plus SRun, PBS, or Torque with MPI run, and so on. Module systems, we support tmod, even from tmod 3.1 up to tmod 4, lmod, and all this is abstracted away. The tests never know what is the module system they're using. That's the system-specific detail. We have invested a lot in sanity and performance checking, so that there kind of a mini language that you can really write your sanity and performance test or extract the values you want in Python code without having to do with complex parsers and state machines. So it's really, you extract the data you want from the output and you really work on it as you would in a normal Python function. And there are also lots of predefined functions to help you. There's also support for test factories, or we call them parameterized tests, where a test can be parameterized on several parameters, and then you can automatically, from a single test class, you can really generate as many test combinations you want. That's quite powerful. We support container runtime, so you can have your tests. You can have ReFrame launching containers to run your test in. Test dependencies, so you can structure your tests such that one test depends on the other. That's quite useful, especially if you have like lengthy compilation processes, and then you just need to run a bunch of tests that reuse that. All these are handled by the runtime, so that's and also when the garbage collection of the test resources, everything is handled by the runtime. Of course, we support concurrent execution of tests. There's also result reports, performance logging. That's quite important. So you can really log the performance through different channels. And the other good thing is that we really invest also in internals. So the APIs internally are quite clean. So that allows the easy extension of the framework's functionality, and also people can come in and develop or extend the framework easily. Overall, the architecture is kind of layered. So on top, you have the user-facing, let's say, thin layers. One is on the right is you see the regression test API. It's the way you write your test. And on the left is the front end, is how you run the framework, which eventually loads the tests, passes them to the runtime, and then the runtime runs them. And the thing is that those levels, they don't speak directly to the system even. So there's even several abstractions, and there's several plugins that this can be changed, or new plugins can be added, which makes the framework quite extensible without having to touch different things as soon as you implement the required interfaces. So the framework, in order to run the tests, it uses a kind of pipeline. So every test has to go through all of those different 5 stages that I show here. So the test is initially set up, a stage directory is created for its resources, everything is copied there. Then the test is built. If then the test is run, that is submitted, for example, to job scheduler or to the local system. And then there is sanity, performance checking, and then cleanup of the resources. Now, the good thing about this design is that you can also easily adapt it to handle dependencies as well as concurrency in different stages. And in fact, for example, here is the serial execution policy, where we assume, for example, that the setup, build, and phase are quite short, and then you have to submit your job, and then basically the serial execution policy will simply have to wait until your job is finishes, and then before moving on to the next. But essentially with this kind of design, then you can just suspend the job as soon as you submit it, suspend the test, and keep it in some queues internally, then move on to the next, proceed with their pipeline, and then start recovering tests as they are ready and finished, and then recover with their pipeline. That's how the asynchronous execution policy works. And then this can be extended different phases. For example, you can have, we can extend that so that the build phase happens remotely, and then you just have even more parallelism there. The nice thing is that all this complexity is handled by the framework. Now, configuration is in ReFrame. Essentially, it has 3 basic sections, and is where the system specific details, let's say, goes. It's where you define the systems, your environments, your tool chains that you want to check, and how you associate them. It's technically it's a big JSON object, which is stored either in a JSON file or in a Python file. And oh, I don't know if it's, I think we have a problem in the house. I hear a beep sound. I don't know if we have an outage, but anyway, let me know if that's annoying. The beep that if you can hear it. Listo. I'm going to jump into example. So here is an excerpt from an actual configuration of the pertain. So we're going to see all this in detail in the tutorial. But here, for example, you have a system. You give it a name. How the host names that basically kind of correspond to that system, so the framework can pick up the right configuration entry. The module system used for that system, and then you start defining different partitions. These have nothing to do with scheduler partition. It's just a way that you make the system, you present the system to ReFrame. So here actually we define the GPU or hybrid node partitions that uses lerm plus srun. And then here is how you get access, for example, to that particular partition. Here you see the environments that you need to test on that partitions. And actually, these are just names that they are later defined in a different section of the configuration. And then you can even define whether the container platforms that are valid for that partition. For example, this one, we have Singularity, and this is how you're going to get the Singularity commands. And then you have a section about environments where, again, you just give it a name. An environment is, in ReFrame, is just a collection of modules and environment variables. They may not even have modules or environment variables set, but then it's just the environment that you run in. And here, for example, you define the compilers so that ReFrame knows how to compile simple tests in those systems. Again, the way it builds things is really, it's not its purpose to do what EasyBuild or Spark do. It just has the necessary stuff in order to be able to build some tests, the code for some tests, and then you define the different programming environments. Now, here is really a very simple, let's say the simplest test. I'm not going to go into more complex tests in this talk, but I'm going to just give you an idea of how a test looks like. So essentially, it's a Python class that is specially decorated so that ReFrame knows that. So basically, that ReFrame picks that and instantiates it and sees as a test. You may not have this, and then you can have your own class hierarchies if you want to structure and your code sets that you don't have duplication, things like that. It's really, really quite flexible. Then you have you need to specify for which systems in the configuration this test is valid for. So this is a list, and by here we mean that that's for any system, and the same from the programming environments. That means that ReFrame will essentially skip the test if you try to run it on a different that is not supported, or in a programming environment that is not supported. And then you specify what is the path to the test, which is here a simple C program. ReFrame will automatically understand which compiler to use based on the extension. You could even here specify directories, in which case it will auto detect whether it's make project or CMake or AutoTools project, and try to invoke the configure or make step. But again, you can also fine tune all of those. And here is how you say how you ask ReFrame to the test to look for sanity. So here is essentially a lazily evaluated expression that essentially says, okay, assert that this regular expression is found in the standard output of the test. And this is lazily evaluated. So it's not being evaluated when the test is instantiated, but it's going to be later evaluated in the sanity phase of the pipeline. And here can be arbitrarily complex. You can even use like a functional style of programming if you want to use this the framework provided function, or you can even write your own functions to process the output, do any post-processing you want, and then decide on whether it's a sane output or not. That's a very simple example I'm showing here. And this is how it runs. So essentially, you just pass the path of the test. There is also a predefined path for ReFrame if to search for test, but here I'm passing one. And then you pass the -R option, which basically says, okay, now run the test. And here you have those you are familiar with Google test. It's like a similar look and feel. So you see that it runs the test on the system and partition that it picked up. So that's the generic and default partition. We're going to see all those in tutorial using the built-in environment. That's the default configuration that the ReFrame comes with. It allows you to run it on literally any system, with of course limited functionality if you don't configure it. I'm not going to go into more details on how the tests are because we're going to have the tutorials. Here is the link to the tutorials. I'm going to, today we're going to do the 3.4 release with the tutorials that we're going to show from tomorrow. So yeah, moving on, performance monitoring, that's quite important. So ReFrame can log its performance through several channels. So either in regular files, or syslog, or graylog. So if you have, this is from a server we have in CSCS that listens and accepts graylog records. And then ReFrame sends those records to that server, and then we can visualize, and then you can have really performance data across time. So as I'm showing here, that's quite nice, because then you can create dashboards and you can see also, you can correlate different tests failing. That's, I think, quite useful. Now, this is a bit on our setup on how we run. So here we have, essentially, our continuous testing works through Jenkins. And actually daily we pull the repository, the latest master from ReFrame, so as to get always the latest developments in the test, plus some private test repository. And then Jenkins logins to the different systems that we're testing, and basically launches ReFrame. So then ReFrame runs and sends data through Graylog to Elasticsearch, and then we can visualize, as I've shown you before. And we have several several categories of tests, which we identify by tags. So generally, you can associate tags with a ReFrame test so that we can easily select them from the command line. So we have some tests that they just test the Cray programming environment functionality, then the HPC software stack, and then we have some a sub-selection of those tests that essentially are maintenance tests run by the operations people before and after maintenances. We have some benchmarks, and we have generally lots of tests that they are used across systems. I know some of you that they have ReFrame production may have even more. So yeah, I think it scales. And generally, it really streamlines the process of upgrades, because as soon as you put it in the process, when everything is green, you really are quite confident that you're not going to mess when you give back the system back to the users. And it really has revealed the last year we had a bit of bumpy upgrades with Gray, and it really revealed a lot of regressions that we have then to come back to the vendor for fixing them. So here is a bit of the ReFrame test suite. You can find all those tests online. There's lots of tests that you can just pick those and adapt them to your needs. And these are a couple of sites that I know they're using ReFrame, because with some of them we have collaborated, like with NERSC, where we have, they're also using ReFrame for their software stack validation, performance testing, and benchmarking, and also acceptance testing. They also use CI/CD, but with GitLab, and to continuously test their software stack. Similarly, Ohio Supercomputing Center, they have a similar setup, and then there's other centers that they are using ReFrame, and certainly there are more that I just keep learning that, we're using ReFrame. Another nice example is that you can use ReFrame for integration test for your code. For example, here is electronic structure library. Is developed by some people in CSCS and generally in Switzerland. And actually they're using ReFrame inside their GitHub actions to run some integration and validation tests. So essentially what they're doing, the GitHub action basically pulls a version from the ReFrame repository, runs the validation tests. And the nice thing is that those tests, that they're valid for that VM on GitHub, the same tests are used for running on the guy's laptop or on Bitstain, and without having to rewrite the test. Just the same test with some slight adaptations, everything in a single place. So there is a small community forming around ReFrame. A couple of days ago, we had 66 members in the Slack channel. So now we are about 70 plus, because people are joining for the tutorial. There is also an effort for, I've put up here, if you want to share your ReFrame test repository, I'm going to do a fork. Just give me the URL and I'm going to do a fork under this group, where I'm grouping together the different test repositories so that people can look into other sites, what they're doing. So there's already there, apart from CSCS, there is a couple of other efforts, but it's still like really under development. So I know that several centers are quite reluctant in sharing their tests, but if you ever want to publish them, then just let me know in the Slack channel so that we can collect them under here. So for those that they have been in EasyBuild user meeting last year, we had lots of progress done. First of all, we released around May, I think, or it was early June, I don't remember, ReFrame 3.0, which had some breaking changes. The way the tests are run is, the syntax is much better now, I think. Also, the configuration was completely revised and rewritten. That's why the old one is no longer supported, especially from 3.4. Improvements in installation, asynchronous execution policy. We have detailed JSON reports at the end of each run session. We had improvements in in test dependencies, support for module collections. We had a nice utility function that basically crawls for different modules. It's like the spider, but not. It works also with the T-mode. So essentially, and then you can parameterize your test to test all of those modules with a single test. That's quite nice. Better verbosity, and then we're having a new syntax introduced in 3.4 on how you can parameterize tests and how you can compose them and how you can dynamically expand the parameterization space. That's quite cool. It's really fresh. And I know Kenneth is going to kill me with this last feature that we also support on SPAC load for loading modules. And ReFrame is not the only tool. As I told you at the beginning, there are other efforts that they more or less started the same period of time. One is the build test, and on Friday at noon, in the afternoon, is going to be the talk from Sazib, and the Pavilion 2. If I would say Pavilion 2 is another tool from, I think, Los Alamos that they're developing. So those two tools, they're using YAML files for tests instead of Python. If I would say some difference is perhaps the view of the things. Where on ReFrame, we're more on from the application view and performance and things like that. And whereas those tools, I see them more from the system side, develop bottom up, whereas I would say ReFrame was top down. If I could just in a single sentence summarize the differences, there are merits in all the three tools, and yeah, you can go and try them, all the three. I think that's good to have some more tools and exchange of ideas. Now, what's next? So the roadmap for the near future, let's say, is we're really working towards enabling you to write, enabling users to write test libraries and composable tests. But no matter what you do, if you don't want to have like a smoke test, a test cannot be entirely generic. You will have to do it. The more serious a test is, it can be entirely generic. With ReFrame, you can basically minimize the effort you need to take to port a test. But with this feature here, we're planning to make it easy so that you can create libraries and then specify. We're going to add some syntax elements so that you say that these are fields, for example, are required, and whoever is using that generic library would be forced to specialize it somehow for his system. But at least this generic part can be shared and common to everybody. So we can follow that project under the link here. Another nice thing we're trying, and there is also already pull request, and we're hoping to merge that soon, is we want ReFrame to generate dynamic pipelines in GitLab and have GitLab run the tests. So then you can have a very nice integration if you're using GitLab in your CI/CD, and you can take your test that you can run manually and then have ReFrame in a single state to like ReFrame CI generate, very similar to the SPAC CI generate. And then that would generate, based on the test you give it, it will generate the actual GitLab jobs and have GitLab run them for you. But then you can use the same test and have ReFrame run them for you. That's quite nice. And then we're planning some improvements in the runtime for increasing concurrency. So touching base with ReFrame developers, so we have settled on a fixed release cycle. So we have dev release every 2 weeks and the stable release every 6 weeks. Our plan is to follow, we have been following the train model since like half a year now. And no matter what release is going to be made. So whatever feature is ready gets in, whatever not is postponed to the next one. So that's we're going to stick to that, as well as the semantic versioning. And And everything is on GitHub if you want to see what's going on. So there are different projects in the releases. So what is scheduled for the release, the sprints, and big thanks to the core dev team. Here are the 5 people with their GitHub accounts. But I should make a disclaimer. We're not full-time on it. It's an open source project. We have plenty of other things that we're doing. So issues might be late to catch the release train. Issues might get spilled over to subsequent sprints. And since we're all CS guys here, priorities might change based on our needs, but we encourage contributions. So if you like the tool, if you think it's useful, and you find bugs or even features, yeah, contributions are more than welcome. And that basically concludes my talk. So essentially, ReFrame is quite a powerful tool that allows you to test continuously in HPC environment. You write tests in a high-level language, and that helps you have portability across HPC platforms by also abstracting away some system details. And has a powerful runtime. For help, there is the mailing list, Slack, GitHub, and bug reports for GitHub. And finally, some logistics about the tutorial. As you might know, it's Tuesday, Thursday, and Friday. And please respond to Victor's email by sending your SSH public key so he enables the access to this virtual cluster that we have set up. And as soon as you join our ReFrame Slack channel, there is a tutorial EUM'21 channel here. So you join that so that we can take any questions or about the tutorial even offline. So that's all about it. And I'm happy to get reply to any questions.
Thank you for the talk. We've got the first question ready for you. I will just ask the first person to unmute.
Hello.
Hi.
So the question is sort of 2 parts, but the main part is for the tests. Is it possible to specify something so that when you have a test, it's non-deterministic? You can specify some, like a central value and then some bounds, so plus or minus. Right? So if I have a test, it comes out, the answer is supposed to be within 1/2 of 5. I presume that would be the case.
Yes, you can do that, both in performance and also when you're doing sanity. So essentially, we do have tests. I mean, I don't have in the presentation, of course, and I'm going to show also in tutorial that you can essentially. We have some tests, for example, it's the Gromex test, I think at some applications where we extract the energy output that is printed by the program, and then we essentially, let me go a bit, just give me a second. So here, in the sanity pattern, so then you can compose different functions or write your own. So actually we extract the data and we say that this thing, assert bounded, there is a function that's called assert bounded, and then we compute the absolute value of the thing we get minus the reference, and we make sure that this is below a threshold. And yeah, you can perfectly do that. And in the performance patterns, which is the performance, is even easier. It's just, you can say this is your reference value and mark this as a failure if you're beyond 10% of that, for example. So you can do that.
And then the second part is, I'm thinking specifically of Gaussian, where the output is kind of messed up because they want to give you some fancy quote at the end every time it runs something. So the output format can vary quite substantially, sometimes from run to run, which makes it very difficult to do. So you have like a regular expression parser for the output.
So that's the beauty of it, because it's not that there is just a parser. I mean, you can write your own regular expression, but in such cases, as you say, if you try to write the regular expression, it's gonna be a monster.
Yes.
So what you can do, that's the beauty of it, because this is fully programmable. So you can have a simple regular expression, get you a list of things back, and then in Python code, you process that and you find your way out by really programming that. And you can write your own function that you have ReFrame extract some of it in a coarser way, and then this passes it to your function, and your function does a further analysis and decides, okay, that passes or not. So it's really in code. You can write normal Python code to do your sanity checking, and use the utility also for ReFrame. Have ReFrame give you some extracted data or things like that, and then you can process it as you wish. It's really very, very flexible.
Okay, thank you.
Hi, if anybody else has any questions, then in Zoom at the bottom, there's a button called Reactions, which allows you to raise a hand, just as Kenneth has done.
Yes, I have a question actually. So, my question was, Vasilios, to what extent have you seen different HPC sites or people sharing tests among each other, and how would they get organized to do that?
Yeah, that's something that it's still hard. I mean, it's because, I mean, in some tests, some centers, they have performance data, so they don't want to share, or they have to go to get approvals of sharing tests and things like that. So I know to whoever I talk, oh yeah, that would be a great idea if we start sharing tests. But whenever I say, okay, just if you make something public, then give me the URL so that I can fork the repo there. It's not yet to the extent that I would like it to be. And towards that direction, one thing is that admittedly, you have to have, if you write a more complex test, at some point you will have to have specific things for your system. And that's where the idea comes in with having a composable test library. So for example, take the Gromax test. There is some components that they are there. I mean, if you have your input files, your output, you can have some non-system specific things. And you can write it in such a way that whoever gets that library would require him to specialize it. You can even do that, but not in such a strict way that would force essentially the users of your base test to be disciplined in that way, in the way they write it. So yeah, but we have all our tests public, and I think most of the centers that they just take ours and they adapt them. But yeah.
Okay, thanks.
Yeah, I see some other people raising hands.
Yes, I'll pass over to the first person.
Yep.
I'll ask to unmute.
Yes, hello. I have a question for a parameterized test, for instance, for all the micro benchmarks you would like for a single run to be able to specify multiple size of the messages and range for the latency or bandwidth you allow.
Yes.
So is that now possible? Because the previous test was not that simple on that side.
What do you mean? Using the parameterized test decorator, you mean?
Yes, for a single run. So obviously, if you make multiple runs, and then you set for each of them the value for the messages you would like to test, then it's as if you repeat the.
So you want the parameterized test, even now with this enhancement, there are going to be new tests, but there you can use dependencies. So you can have like the part of building the OZU benchmarks, for example. it can be in a single test where the others are depending. So then you can, the run test will run really fast and be submitted.
Okay.
And
but then I have the impression from what you described that you would still have at the end multiple execution of the benchmark for a
yes,
single message size. And my question is more: would it be possible to make the full run that then, of course, is testing multiple message sizes, and then you define as parameter that for a subset of the message size you expect a certain value with some tolerance?
Yeah. No, this you can. Yeah. This you can do it even right now. For example, you specify which, because in the output essentially you can have multiple performance patterns. So you can define, we're going to see it in the tutorial where I have the stream benchmarks and I'm extracting from the output the value for copy triad, etc. So there you can extract the value for the different sizes and have references for each one of those. If I'm getting what you're trying to do.
Yes, that's exactly what it could be done, but then I was thinking if there is another way to abstract maybe for input parameters. So therefore, in this case, the message size. And then for a set of inputs to provide expected value together with a tolerance range. And I have the impression it's not yet.
You can, we can discuss this in the chat, but I think you can do it if I understand it, because you can parameterize your test with any set of parameters, and it's up to you how you generate the list of parameters that you pass. So you can generate combinations of message sizes, and I don't know if you want different runs or in the same run. I don't understand what exactly you need to parameterize. That's the thing. Perhaps we can discuss, but I believe it's doable.
Okay, thanks.
So going to interrupt the questioning there. We've opened a breakout room, so for the next few minutes, if you wish to ask Vasilios questions, please enter the breakout room. This is just to allow us time to, for the next speaker to set up, ready for the next talk. The next talk will start in about 8 minutes' time.